So when you look at a tree, what do you see? Leaves, right? Branches, maybe a good spot to sit in the shade. But what if I told you you're also looking at one of the most amazing machines for fighting climate change? We're going to break down the incredible science of how trees literally pull pollution out of the air and turn it into solid wood. And our story really kicks off with this massive global movement called #TeamTrees. It was backed by all sorts of creators and philanthropists, and they had a simple but truly ambitious goal: get people all over the world to plant a ton of trees. And we're not talking about a few thousand or even a million. The goal was 20 million trees. I mean, to put that in perspective, that's enough to cover an area the size of Manhattan twice. That's the kind of scale we're talking about to make a real dent. But that brings up a really big question, right? We all hear that planting trees is good for the planet, but how does it actually work? How can one little sapling in the ground fight a problem as huge as global climate change? Well, to answer that, we first have to understand the invisible problem that all 20 million of these trees are designed to fight. And it's a problem that's floating all around us, in the very air we're breathing right now. Okay, so the main culprit in our climate story is carbon dioxide, or CO2. You can think of it like a blanket wrapping around the Earth. For years, as we've burned fossil fuels, we've just been pumping more and more of it into the atmosphere. It traps heat, and now that blanket is getting dangerously thick. So tackling this whole thing requires a two-pronged attack. First, and this is the obvious one, we have to stop adding more CO2. We gotta turn off the tap. But the second part is just as important. We need to find ways to actively remove the carbon that's already up there. And that is exactly where trees become our greatest allies. All right, now for the truly mind-bending part of this story. Seriously, this idea kind of goes against everything our senses tell us. We're about to see how a tree is basically a vault for carbon, and how its solid, heavy structure is actually built almost entirely out of thin air. Just picture a huge 80-foot-tall tree. It's solid, right? It's heavy. You can knock on it. It seems to be made of, well, wood. But if you could break that wood down to its most basic atomic building blocks, you'd find it's almost entirely made of just three things: carbon, oxygen, and hydrogen. The stuff that gives a tree its strength and structure is called cellulose. And as you can see here, cellulose is just a long repeating chain of those same three atoms. But I want you to focus on that one key ingredient: carbon. That is our direct link to the CO2 in the atmosphere. Okay, get ready for this because it's pretty wild. Every single atom of carbon that makes up the solid wood of that giant tree was at one point just floating around in the air as part of an invisible CO2 molecule. The tree literally inhaled its own building blocks. So how in the world does a tree pull off this magic trick, turning an invisible gas into a solid object? Well, the answer is a brilliant biological process called photosynthesis. It's like this green engine that nature has been perfecting for hundreds of millions of years. You know, the recipe for photosynthesis is actually pretty simple when you break it down. The tree takes in three key ingredients: carbon dioxide from the air, water that it pulls up through its roots, and of course, energy from the sun. It mixes all this up inside its leaves and spits out two crucial things: glucose, which is a simple sugar, and the oxygen that we all need to breathe. So just imagine, every single leaf on a tree is its own tiny solar-powered factory. It's constantly running this chemical reaction, taking in raw materials from the environment, and just churning out these tiny, energy-packed bits of sugar called glucose. Okay, so the tree has created all these little packets of energy. But how does that turn into, wood? How do you get from a simple sugar to a solid tree trunk? Well, that glucose doesn't just hang out in the leaves. Nope. It gets shipped all over the tree from the deepest roots to the very highest branch. It does two things. First, it's the fuel for the tree's day-to-day operations. But even more important, these glucose molecules are the actual molecular Legos the tree uses to build new stuff: more leaves, bigger branches, and those dense rings in its trunk. And here it is, the final, crucial step in this whole construction project. The tree takes those individual glucose molecules, each one carrying that carbon pulled from the air, and links them together into these long, incredibly strong chains. And those chains, that's cellulose. Cellulose is wood. The transformation from invisible gas to solid matter is complete.
So, now that we've seen the incredible science happening inside just one single leaf, let's zoom back out. Let's connect this tiny process to the massive impact of something like #TeamTrees.
And here's the simple, powerful truth. The very act of a tree growing is the act of cleaning our air. With every single inch it gets bigger, it is actively pulling carbon dioxide out of the atmosphere and locking it away, sequestering it inside its own solid structure for decades or even centuries to come. And what makes these efforts so powerful is just how direct it all is. The model is beautifully simple. $1 plants one tree. It translates a small contribution directly into a brand new natural carbon-storing machine being put into the ground. It makes a huge global problem feel tangible and solvable. So we're left with this one powerful idea. We've seen how a single tree is this remarkable machine that turns air into wood, locking away carbon in the process. So the real question is, if one tree can do all that, what's the power of 20 million? What happens when we decide to build a forest?